Very good morning. I am Dr. G Nallasivan, working as professor in PS and CS department. In today's class, we are going to discuss about the software engineering, basics of software engineering, right from what are the characteristics of software engineering, what do you mean by a process versus product, which one is good, what is the classification of process versus product, and list of framework activities like that until we are going for discussing about what do you mean by scheduling, risk analysis, all these things we are going to discuss. Right. The very first thing is what do you mean by a software? Software is nothing but it is just not a simple program code. It is an executable code which serves some computational purpose. Software is a collection of computer programs that you already know. It is an information the people or developer who are writing the program for the purpose of satisfying the requirements stated by the customer. That is important, right? And regarding the software product, I already said about the distinguishing or classification between the software process versus software product. Which one is more important that everyone should know, right? I just take into account the educational system, the college, how college is functioning, right from the class test, right from internal assessment, CAT assessment, continuous assessment test, then university examination, all these we are conducting, MCQs, all these are considered to be called as a process. Then finally they are going for writing the university exam. It is what is called the outcome of the project. In terms of result is what is called the product. Unless we have a very good process, we are not able to get the product as an output. So process is that much important, right? And what are the attributes of a good software? We are going for efficiency, usability, dependability, and maintainability. That we can see one by one. And what are the characteristics of software? Before going for developing the software, you should understand the basic characteristics of software. Software is engineered or developed. It is not manufactured in the classical sense. The very first thing. Like unlike the manufacturing of car or manufacturing of bolt, nut, everything is something called as manufacturing. We are using the term called as manufacturing. Here we are using the term called as developing or engineering. We should always use the term we are engineering the software, we are developing the software, irrespective of the manufacturing of this software. And the software does not wear out. So software does not wear out in the sense that if something which is dynamic in nature, say for example in your house we are having the fan is running, it should be affected with wear and tear. Friction will be occurring. They are going for using oil or pull out oil something to make it is a smooth function. So here we are prolongedly using the software for more number of years. It does not wear out. That is the concept. And third one is, although the industry is moving towards the component based assembly, most of the software continues to be custom built. Custom built means what? So if it's a manufacturing of a car, we have so many components in your account, some radiator, carburetor, engine, everything is called components. We are going for assembling all these things to manufacture something. Unlike software, the customer is coming, he is taking all these requirements, we are going for building the software. So software is to be called as custom build rather than it is a component based assembly. And what are applications of software? We can use software in anywhere. Even the conductor working in the bus is having his own miniature software for printing the tickets, and real-time softwares are there, system softwares are there, business softwares are there, engineering and scientific softwares are there, embedded software, personal computer software, web-based software, and of course we are in the artificial intelligence arena or scenario that also have software, right? So what do you mean by a layered technology? If you want to complete or build a good software, it is something called as layered technology. So it is a method of a systematical, disciplined and quantified approach to the development, operation and maintenance of software. We are incorporating various tools and methods used to complete the project, and finally already said that process, and ultimately we are focusing on the quality. Quality is that much important. Quality means what? It's a degree of excellence. Quality means it is a confirmation to requirements. Quality is when the customer comes back, not the product. Right? So the ultimate aim of developing any software is we have to attain the quality by incorporating the tools and incorporating certain methods and following a systematical process until we are going for delivering the good product as an output in terms of maintaining the quality. 5 generic process framework activities. You can take into account any type of life cycle models. You can take the 5 things are that much mandatory, that is that much important. One is called communication, then planning, modeling, construction and deployment. These 5 process, communication, planning, modeling, construction and deployment will be applied to all the life cycle models. We will discuss some of the life cycle models here. It should describe a unique set of framework activities for the software process to adopt. The first thing is called waterfall life cycle model, and some added advantages of iterative to the existing waterfall life cycle model, prototyping model, incremental model and spiral model that we will discuss. The very first thing is called waterfall life cycle model. Waterfall life cycle model is called the basic traditional life cycle model. During at the revolution of software engineer or software companies, the very first thing they have in our hand for development of the software is waterfall model, waterfall life cycle model. Another name for waterfall model is linear sequential model or classical life cycle models. Here the requirements are well defined and stable. It is systematic. It is sequential approach to the development of software. Right? Here we can adapt and apply all the things we discussed in the last slide about communication, planning, modeling, construction and deployment. These are all the 5 things we are applying for the waterfall model. Of course, if you want to develop any product, if you want to apply any one of the implementation things, we should have certain hierarchical models for the development. That is ultimate aim of framework activities in software engineering. In waterfall model, here we incorporate 5 things called as communication, planning, modeling, construction and deployment. This stage by stage, it is something like ladder in shape, of course, isn't it? Communication, after that one step below that of communication, we have planning and modeling, construction, deployment. It indicates that something called waterfall. Waterfall happens from top to bottom, not from bottom to top, right? Communication. Take into account the communication. What needs to be communicated? In communication, the customer who is having the problem domain will come and approach in the software company. So the designated people involved in the communication phase is called as system analyst or program analyst. The conversation takes place between the communication analyst as well as the customer. The analyst, after having gathered all the requirements stated by the customer, he needs to go for planning and to prepare for certain document. The name of the document is called as software requirement specification. Then what else he needs to plan? He needs to plan the timing, he needs to plan scheduling and which time we need to complete the product and what time, what much amount we are investing for completing the project, budget, scheduling, time, cost, manpower, everything he needs to plan first. After that, he needs to prepare the document called as SRS. Of course, we are modeling. What is the necessity of modeling? The modeling means the requirements should be fulfilled with any one of the modeling like use case model, UML based modeling or activity diagram, swim lane diagram or data class diagram or class diagram, whatever it is. These are all the various modeling approaches available for converting or drawing the requirement in terms of modeling. Anyone who is in the development or design phase who just see the diagram of modeling, one can understand what we are going for development and what are the things we need to follow for the development of the construction of the software. And after that, construction means combinedly called as code and test, and finally go for deployment. And construction coding means the developer who needs to develop the product that is available in the modeling. And testing is of course either manual testing or automated testing. We need to test all the developed product and find out any errors or bugs present in the software. If at all he comes across any errors or bugs, he needs to write the test case and that should be rectified. Finally, we go for deployment. We are at the end of the development. We are going for wrapping up of the software. The wrapping up of the software itself requires certain kind of testing called as acceptance testing. Who else needs to accept? The user has to be accepted. The user has to accept, right? And while go for acceptance testing, then we have two things. One is called alpha testing and beta testing. Alpha testing, when the product is nearing completion, the test carried out is what is called alpha testing. After the product has been developed and delivered to the market, we are going for testing, then it is called beta testing. The user may be from two persons. We should have the knowledge of stakeholders. As a software company is concerned, the stakeholders we have developer, team leader, tester, trade union representatives, analyst, right, domain expert. These are all they are all company called as a stakeholder. And user. The user is both from the developer side as well as from the customer side, who we should satisfy before delivering the product. Of course, what is the use of waterfall model is easy to understand, and it has well defined input and output. It helps project manager in proper planning of projects. It provides a templates into which methods of analysis, design, code and support can be placed. Of course, drawback, it is one-way street. One-way street in the sense that nobody comes back. It lacks overlapping and interaction among phases. Model does not support delivery of system in pieces. And these are all supposed to be called as a drawback. And one more drawback we find it in the waterfall model is what is called the missing of feedback from the earlier stages. That will be fulfilled in the another phase of waterfall model called iterative waterfall model. And what are the phases? I already explained in the diagram, first diagram itself, about the planning, communication, developing, construction, all these things. In elaborately, we can call it as a phases of waterfall life cycle model. Yes, so the very first thing is called feasibility study. Second one is called requirement analysis and specification. Third one is design. Fourth one is coding and testing. Fifth one is integration system testing, maintenance. These are all the phases that is really involved in the software company. If at all they go for classical waterfall model. The very first thing is what is called feasibility study. What do you mean by feasibility study? Feasibility study is nothing but finding the possibility of carrying out the product, whether we are going for proceeding or developing any product or not, right? Say for example, if suppose your father or mother, your mother wants to buy vegetables, ask you to buy vegetables to you, and you are given with 500 rupees and list of vegetables they have written and give it to you. You are going to buy the vegetables in the market, and what are the feasibility study you can carry out? The very basic thing is the given amount is sufficient for you. This is one question you have to ask. And the list of vegetables they have written is really available in the market or not? And on what time you need to go to the market, and which time you come back to the house, and by means, by vehicle, whether you go by walk or by cycle or by bike or by car or by bus. And after that, if at all you are buying or purchasing the vegetable, you are not having sufficient amount in your hand, what else we need to do? Whether we have the ATM card in your hand or not. If at all you have lost your money, then what else we need to do with the purchase? And if at all any road blocks happened in your regular way, what are the various ways or alternative ways you have? This is what is called feasibility study. Just for the amount of 500 rupees, what are the feasibility studies we are carrying out? Just imagine the project is something called in terms of crores. The people is investing, the customer is investing in terms of crores. How much feasibility study you have to carry out? And the expert is going for feasibility study and finally they are recommending the document whether to proceed to the next stage or not, whether we can carry out the project or not, whether we are developing the project or not. The expert will give solution. And second is what is called requirement analysis and specification. In requirement analysis and specification is something called as stakeholder analysis. I will explain about the stakeholder, who are all the stakeholders involved and what are the types of stakeholder. If at all any project development, many number of people are involved, surely we have the conflict. One stakeholder will raise certain question that should be accepted by another stakeholder. So it is the collective responsibility of the team, analyst, to solve or resolve the conflict among the stakeholders and finally attain certain question, right? And finally, the second we go for design. What else we need to design? We need to design the data. We need to design the architecture. We need to design the interface. We need to design the component. These four things we need to design in the design phase. Component we have to design, we have to design the interface, we have to design the architecture, we have to design the data. The designated people involved in the design phase is what is called a design engineer or software architect who needs to carry out this work. And after that, we are going for the development, coding. Who is running the code? Who is writing the code? This is programmer or developer is writing the code. And keeping the specification of design in his hand, the developer is going for a development, and after development is over, the developer has to test his module with his own data. That is important. The developer has to test his module with his own data. Then that kind of testing is what is called unit testing. So unit testing is done by the developer, not by the test engineer. This is an important question that usually asked in companies, that who is responsible for unit testing? Developer is responsible for unit testing rather than the test engineer, of course. After that we switch on to the next stage called as integration and system testing. After all the unit testing is done by the developers, we are at the stage of integrating all the modules together. So integration involves all the modules are integrating together. A standalone module will function well. Most of the softwares will fail during integration. A person, say for example, a person staying in the room in a hostel, a student staying in the hostel, a single student staying in the hostel, no problem for him because he has to get the input, he has to proceed or manipulate anything, he has to give the output, no problem. If at all, four students residing in the same room, the conflict will occur between these four persons because the influence of the two or three people will have an effect on a single person. Then it should be avoided. Then the integration happens there. Then what are the types of integrations we are carried out? In commonly called as incremental integration testing and non-incremental integration testing, in broad way we are classifying. In both the two types of testing, we have the bottom-up approach of the integration testing, top-down approach of integration testing, big bang approach and sandwich approach. Top-down integration of integration testing starts from top to bottom and go for integrating all the modules together. In top-down integration testing, if at all any module which is under construction, not yet completed, then we have to replace this particular module with stub. So stub is called as a dummy stub program. We are going for integration. After the project has been completed, we are replacing the stub with the original module. And regarding the bottom-up approach, in here we have the workers module. We are going to complete the workers module at the bottom, and we are going for incrementing in a bottom-up approach. And we go for the main program is not at all completed. Then go for integration testing is tedious one. Then the main program is replaced with the drivers. So driver is present in bottom-up integration testing and stub is present in top-down integration testing. And non-incremental integration testing is something called as big bang approach. Big bang approach is nothing but we are simultaneously testing all the modules together at the same time. Irrespective of top-down or bottom-up, We are simultaneously testing all the models together. Is called Big Bang approach. And the combinations of combining top-down integration testing and bottom-up integration testing is something called as Big Bang sandwich approach. And finally go for maintaining all the softwares together. This is what is called classical waterfall model, and these are all the steps involved in any framework activities. These are all the steps involved. And feasibility study I already explained, requirement analysis and specification explained, design, coding, integration system testing, alpha, beta, everything we have discussed. Something, the problem with the earlier waterfall model is having the lack of feedback. So if you add a feedback path with every phases, it is what is called iterative waterfall life cycle model. Here we have the feedback from the previous stage to the first stage available, and all these things, rest of the things are same. Now, what do you mean by prototyping model? What is the term defining prototype? Prototype is nothing but it is the model or demo we are developing and showing to the customer. Prototype is nothing but some thermomechanical like structure we are developing, like it is something called as a finished product. The developed customer is having certain anxiety that how this product will be looking like. Instead of waiting for the 10 months of period for developing the software, we take only 15 days to prepare the prototype and show to the customer. The customer, after seeing his product, he will find that our product will be looking like this, and these are all the steps involved in developing the product. As the customer is satisfied with the product, we are at the prototype is achieved and it is accepted by the customer. We have the headache of the changing requirements stated then and there by the customer. Clarity, risk identification, as the customer is involved in the prototype itself, good environment, take less time to complete. The drawback with the prototyping model is called a high cost, slow process, and too many changes expected by the customer during the prototype development. And what do you mean by spiral model? The spiral model is a combination of iterative development process model like prototyping model and sequential linear approach like waterfall model. Is combining two things to have. Barry Boehm proposed this spiral model. Here also 4 phases involved called planning, designing, construction and evaluation. Of course, the spiral model is having anchor point milestone is present in the spiral model. The very important aspect available in the spiral model is what is called risk analysis, emphasis on risk analysis. Very high risk will be mitigated, will be monitored, resolved in this approach. So, spiral model is that much important. There is a diagram of spiral model stating starting from the center of the spiral, it is keep on increasing in the clockwise direction. Here 4 phases available identified. One is objectives, determination and identify alternative solutions, and second one is identify and resolve risk, and third one is developing the next version of the product, and fourth one is review and plan for the next phase. This 4 is what is called the quadrants present in spiral model. Most of the companies are using this spiral model for their development as it is having a sound methodology of resolving risk. Anchor point milestone is also present in this particular life cycle model. Advantages, risk identification at earlier stages, high risk projects will be suitable, and flexibility for adding functionality. Of course, drawback is costly one, risk dependent and not suitable for small projects, and it is difficult to meet the budget. So coming to the planning, what else we need to plan I already explained. The planning must be splitting into various several activities like how much effort is required to complete each activity, how much calendar time is needed, how much will be the completed activity cost. And planning objectives, understanding the scope of the problem by the analyst, make use of past historical data, estimate effort or function or size, define a project schedule. And the characteristics of software project planning, we are going for defining the scope of the project, resources we are using for developing the product, time to complete, quality of the project, and if at all any risk mitigation should be avoided. This is one way of time, resource and quality. And types of project plan. We are going for developing the plan for software development, quality assurance, validation plan, Configuration, of course, configuration management plan, maintenance plan, and staff development plan. And structure of a software project management plan is called project summary and project planning. And software project scheduling. Scheduling is more important. We are developing the product, and what time we are going for developing, and what time we are going for the distributing or delivering the deliverables to the customer. All these things play a vital role. And regarding the project scheduling process, we need to identify the activities and what are the various activities we need to do. Identify the possible dependencies. If at all going for developing any product, whether it requires the data should be supplied from any other else. That is what is called identification of the dependency of the project. Estimating the resources. How much resources available for completing the product? What are the resources we require for completing the project? Assigning people to conduct activities. We are assigning the roles and responsibility people for every activities to be completed, and create activity network and bar chart for the preparation of the scheduling. This is what is called the basic project scheduling process diagram. Scheduling techniques. Of course, we have so many different types of techniques available for scheduling. That is taken care. That is involved in the companies like MNCs. And the software project does not differ greatly from scheduling of any multitask engineering effort. The various scheduling activities will be carried out through this technique called WBS, called work breakdown structure, activity chart, project evaluation review tech called PERT chart, Gantt chart, and critical path methods. The very basic diagram of WBS. WBS consists of the complete work breakdown structure, hierarchical decomposition or breakdown of project or major activity into successive levels. The project is divided into 4 major classifications called design, implementation, testing, right? The design, of course, we have 2 different types of design. One is called data design and user interface design. And testing, of course, is classified into 2 things. One consists of module testing and data testing, and another consists of design and citing, website testing. Sorry. The PERT chart called project evaluation reviewing technique. The PERT chart is a project management tool used to schedule, organize, and coordinate tasks within the project. PERT methodology is used by the US Navy in 1950s to manage the Polaris submarine program. It is an event-oriented technique. PERT is a probabilistic model. Like Gantt chart and PERT chart can be the both cost and time management systems available in their tool. And like Gantt chart, just to see this diagram, it is horizontal bar chart and it is developing the production control tool. It is named after a Henry L. Gantt. Gantt, an American engineer and social scientist, frequently used in project development, learning research. Just to see this Gantt chart, one can easily find out the timing required from January 19th to February 19th and mid of March 19th for planning. And of course, the research of work will be carried out from February starting, and it will be completed in March 19th. And design aspect from March 19th to April 19th. Implementation from April 19th to July 19th, and follow-up action from June to July. On seeing this, one can easily interested to fix the people, fix the scheduling activities, and complete as early as possible according to the following of scheduling present in the Gantt chart. Of course, risk is a vital role for any software development. Without risk, we cannot able to have. In your regular life also, we have so many different types of risk. Suppose you people are going for traveling from, say for example, one place to another, X to Y, which is around 150 kilometer. You are going to use bus for your travel. And what are the types of risk you come across? Just imagine. You should have the amount, sufficient amount in your hand. Say for example, you are going to write certain exam which is away from 150 kilometers from your native place, and go for writing and coming back. Just analyze what type of risk you come across. You have to, say for example, your examination time is from 10 o'clock. You should get the bus by 5 o'clock. You take around 3 hours for traveling. So you have to get up and make ready for catching up the bus by 5 o'clock, 5 a.m. That is first risk. And second one is the bus should be convenient enough for you to make the destination within the 3 hours of traveling. Your co-passengers should cooperate in all aspects. That is important. If at all you lost your money, you should have alternative ways of paying the ticket charge. A bus met with an accident. Just imagine the driver is having met with the meeting with an accident, small accident, and how effectively you are managing the time for reaching the destination. So these are all something called as the risk. Before going for writing the exam, all type of risk you are assessing. Like even in the companies also, we are at the stage of analyzing all types of risk. And software risk is it is a Webster risk is the possibility of suffering loss. Risk in a project or program is a measure of the ability to achieve objectives within the cost, schedule, and constraint. Of course, we can classify the risk into two things. One is called classification 1 and classification 2 types of risk. Classification 1 risk is called project risk, technical risk, and business risk. Classification 2 type of risk is called known risk, predictable risk, and unpredictable risk. The classification 1 is called project risk, technical risk. Project risk is called the project schedule will slip. We are not going the right way to complete the project. The cost will be increasing as we are not estimated in the beginning. Right? Project risk plays a vital role for taking into account while go for development. It is called lack of schedule, lack of resources, customer and requirement problem will be alerted even in the first stage itself. And technical risk, of course, we don't have that much of a technical tool available. The product quality is not up to the mark. The technical risk is real. Then implementation may become difficult or impossible. Identify the potential design, implementation, interface, verification, and maintenance problem. And of course, business risk. After completing the product, how this product will be reaching the market risk. What are the strategies we are following that is lacking? The strategic risk, the management risk, of course, and budget risk, of course. These are all considered to be management risk. In type 2 classification of risk, there is two things. One is called known risk and predictable risk. Known risk that can be uncovered after careful evaluation of the project plan. Before going for executing the project and before going for planning all these things, certain risk we easily identify, like traveling by bus. If you reach the destination by 10 o'clock, we should catch the bus before 4 o'clock. Then we can easily avoid that kind of risk, like in project also. And what is the predictable risk? Predictable risks are extrapolated from past project experience. And unpredictable risk is something we are not able to analyze, predict certain things. Say for example, earthquake occurs, the building. Unfortunately, we are going for giving leave. Unfortunately, we are going for giving leave to the companies for many number of days. We are lagging with your schedule. That unpredictable risk is also a vital role. And risk strategies once again may be classified into two things: reactive risk strategies and proactive risk strategies. And risk in software development project also poorly defined requirement, client requirement changes frequently, poor techniques for cost estimation, and dependence on skills of individual developers. Then go for managing the risk. If you go for managing the risk, we should have two things. One is the risk assessment and risk control. We need to identify, we need to analyze, we need to plan, track, and controlling the risk with these two things. And risk assessment is the determination of qualitative value of risk related to concrete situation and recognize the risk. And second, risk identification, risk analysis, and risk prioritization. Identifying risk is something called systematical attempt to specify to the project plan. And the risk identified checklist, how we can find out this risk means we have certain checklist in terms of product size, business impact on the development, customer characteristics, process definition, development environment. And activities in risk identification phase is the very first thing is identifying risk, defining the risk attributes, the document we are using, communicating with the risk identification phase, and analyzing the risk. All items are analyzed using different criteria. activities in risk analysis, group similar risk, determines risk drivers and derivers, determine sources of risk and estimating the risk. Task prioritization project focus on most server risk by assessing the risk. R will be likelihood of risk coming trace, and S is a consequence of the problem associated with it. If at all this particular problem occurs, what are the various consequences we face with this problem that should be taken into account. And prioritization will be the product of likelihood of the risk and the consequence of the problem. And risk control is called the process of managing the risk should outcomes. And risk management planning, it's a plan for dealing with each significant risk, and the strategies we are following the risk management planning is risk avoidance, risk monitoring, risk management and contingency planning. And risk resolution, resolution the execution of the plan for dealing with each risk, and output of each risk resolution phase is risk status, acceptable risk, reduced rework, corrective actions, problem prevention. Monitoring. How we can monitor the risk? The risk may be monitored with the R plan, which is nothing but risk mitigation, monitoring and management in the software project plan, or the risk management steps are organized. Then coming to requirement engineering process, we are already explained about the feasibility study. The requirement engineering process, we have the 7 stages of requirement engineering process, and it is a systematical approach to illustrate, organizing, documenting the requirement of the system. The document is nothing but software requirement specification (SRS). Companies to companies, the name may be different. In some companies, they name it as software requirement document. Some companies, they name it as functional requirement, functional document, all these things. And the types of requirement, of course, we have 2 different types of requirement. One is called system requirement, another is called user requirement. The system requirement, all the system related aspect of functions, services and operational constraints will be done, elaborately executed in system requirement. And user requirement is something called as we people going for the development or the customer who is preparing his own document, what are the things to be clarified, what are the things to be developed will be clearly documented. That kind of list is called requirement, is called user requirement. And regarding the types of requirement, the 3 different classifications of requirement is functional requirement, non-functional requirement and domain requirement. Functional requirement, it is something called the customer should provide a statement of service. It should be clear how the system should react to particular inputs and how a particular system is functioning. Say for example, I will explain with some ATM machine, automated teller machine, where the ultimate purpose of ATM machine is to get the money, right? It is one kind of functional requirement. What else we need to do with the functional ATM machine is we have to just insert the card and we should type password or PIN number. After that, the amount we have to give and types of banking, either savings bank or current bank. And after that, we are going for delivering the product or getting the money and receiving the receipts. So these basic thing we expect from the ATM machine is what is called functional requirement of the ATM machine. We have to insert the card, we have to get the PIN number, we have to insert the amount we want to withdraw, and we have to withdraw, deliver the amount and the clarity and bill we have to receive. This is what is called functional requirement. What is the non-functional requirement from ATM machine? Security. Non-functional requirement is something called as constraints and reliability, response time, storage requirement of the system. Regarding non-functional requirement, the clarity of the display we have in ATM machine, the security, whether we have security or not. Then AC, air conditioning system available in the ATM machine room, clarity of display, timely, the response time of the ATM machine. This is what is called something non-functional requirement. Without non-functional requirement also we can take the money, but the ultimate aim of meeting out the functional requirement is that much important when compared to non-functional requirement. Domain requirement, of course, in which domain we are going for the development, it should reflect certain characteristics of the domain. And problem with the domain requirements is called understandabilities and incompleteness. They refer to domain requirements. The client manager, system end users, client engineer, contract managers are responsible for meeting out all the requirements. I already explained about the SRS software requirement document. It is something called software requirement specification. Yes, users, customers, and marketing personals are the users of the SRS. Software developers, test engineers, product developers, or managers, maintenance engineers are involved. So up to this, I can conclude with the various. So in today's presentation, I have covered what do you mean by software engineering, what are the characteristics of software engineering, what is the difference between the process and product, and what do you mean by the framework activities, right from waterfall model, prototyping model, or iterative waterfall model, and what do you mean by risk, how we can come across the risk, what are the methods we are following for remedying or preventing the risk, and after that scheduling, of course scheduling in terms of a PERT chart or Gantt chart or work breakdown structures, and what do you mean by document called SRS, that is we have covered. Thank you for watching this video. In our next slide, next presentation, we will elaborately discuss about all this in future. Thank you.